As I just mentioned in the other video, this strange technical expression measures of central tendency is really a sort of convoluted way of talking about averages. But it's an expression that you might see here and there and everywhere. So an average, what is an average? Well, an average is simply one number that is meant to summarize the size of the numbers in the whole set. So we want to try and get some kind of representative number for the whole set of data. Of course, the problem arises because in the data set we're going to have different kinds of numbers, and so we're going to have to figure some of which are going to be repeated, some of which are going to be much bigger than others or much smaller than others, and so on. And so what we need to do is we need to figure out a way of choosing a number that represents all of them. Now, in most people's mind, when we talk about average, what they think of is what is more technically called the mean. It's actually more technically, but not really completely technically, as we're going to see in a minute. But the two words are not exactly the same thing, because for instance, median, mode, and there are other ways as well of computing averages, are also averages. They are also single number summaries. Okay, so when we talk about the average, although keep in mind that for a lot of people that what it means is the mean, and we're going to see in a second what it is, but it can mean anything from a technical point of view. So when you read an article and they're talking about an average, start from the assumption that they're talking about the mean, but always look into it and make sure that that's what they're using, or if they're using something else, identify what it is that they're using. So let's have a better look at this thing called the mean. Well, its proper name is actually the arithmetic mean, and as you probably know very well, this number is computed as follows. You take all the data that you've observed and you add them up. That's what that strange Greek symbol sigma signifies. So this number here, this letter here, it's a Greek letter sigma, and what it represents is a sum of all the data that we've observed, and then we divide by the sample size, that is how many data we observed. Now, there are two special symbols that are used to characterize the arithmetic mean. One is an X with the bar on top, or pronounced, not surprisingly, X bar, and that is the symbol that we're going to use when this mean comes from a sample. So in other words, when we're dealing with this as a statistic. However, sometimes, very rarely, but sometimes, we may be able to get the mean for the whole population, in which case we're dealing with this as a parameter. More usually, what happens is that we consider the mean of the whole population as a hypothesized value about which we're going to try to find something out. So we usually are going to compute the sample mean, x bar, and we're going to try and figure out something about the population mean, which is mu. Once again, remember, this is the average for most people, but most people don't even notice the adjective in front, arithmetic. And the arithmetic mean is only one of many possible means, which are computed with through several different methods and mathematical computations. So let me tell a little bit more about the mean, something that hopefully you may not have thought as much before. And that is, why do people use the mean so much? Well, there are many good things about it. For instance, it uses all the pieces of information, unlike some other averages that only use some bits and pieces here and there. For instance, the mode only looks at the one which happens more frequently and totally ignores everything else. So this is a good thing about the mean. It does not throw away any bit of information. Also, it is very easy to compute and even easier to program. Every calculator, even a $3 calculator you can find in a grocery store, will be able to compute the mean. Very, very easy to do. And we're going to see in the winter term that it is very useful in inferential methods. It again allows us to do all kinds of calculations. And it also has a fairly easy interpretation. Actually, it has several easy interpretations. We're going to see a couple of them today. But one of them is the following. Let's say that these are the values that we obtained from our data set, and let's pretend that we're placing them along some kind of a piece of wood. Then the mean represents the point where if we put a wedge, that we're going to be able to balance the beam with all these dots on top of it because of their distance from it. Okay, I'm not sure if you have seen this interpretation before. We're going to see another one just as we come back for the next video.